All right. You know, recording.
Since you're recording, so if you have to watch the video later, do you still send you the keywords?
Well, the video usually will have questions. It's like 3 tiers. If you show up, there's nothing to do. Watch it live, like 4 people right now, they email me and have to do it with the keywords. If you aren't there live, then you watch the video and answer the questions that are, go along with it.
Okay, I was just thinking Mondays in the library, if I don't actually
Oh, yeah.
show up. So, okay,
And the questions aren't hard, they're not like testing you. It's more like making sure it's questions as you go to make sure you're watching it. Like, what am I doing at the beginning of the video? You know, chances the choice of sitting down, or standing up, or opening the door, whatever the case may be. That's things like that.
okay,
Same with all those independent work videos. So the videos that I posted that you can watch for independent work, the questions aren't like to make you think. It's just proof that you watched it, paid attention to it. So I'm glad you asked that, because I don't think I clarified that when I talked about those videos that you can earn points for independent work. I think it's an easy way to get points for independent work. Since it's such a wide variety, you can find one that actually interests you.
oh, I did see this, I don't know if I can find the picture. This really cool picture of 2 rivers that come together, but they don't blend because of the sediment or something in it.
Yeah.
And I thought that was really neat, so.
Those are neat. I've seen, the elk and the canal do that as well. All right, less than a minute left. Go. Morning. Mark is here. And it is 8. Make sure that I have everybody before I get started. If you're online, I don't know if I can hear you anyway, but I'll try. So, have Black online, Davies is here, Lozelle is online, Sims is going to a volleyball tournament match, whatever the word is. Valdez is not here, Page is not here, Fisher is online, Vega is not here, Strickland is online, Whitaker is not here, Stanley is not here, Faulkner is here, Cunningham is here, Newton is not here, Mark, Musa, it is Musa, right? Okay. Is here. Sisse is not here. Davis is online. Smith is not here. Dunlap is here. Carr is not here. And Fawcett is not here. That look good to everybody? Sound good to everybody? All right. Oh, Sims is online. So anyway, again, if you're online, obviously you need to send me an email, and I'm going to specify, because now that I think about it, I don't think I've done it before. So make sure you send me the email before 9 a.m. Send me the email with keywords before 9 a.m. Anything after that, you need to do the video. Reason is people before you have buddies, so they say, hey, watch this for me, and then give me the keywords. So, that's just the way it is. Any questions about that? You guys probably would because you're here, but all right. Let's get started. I'll do some announcements and some reminders before I jump into the PowerPoint. I have to pull it up here. Okay. Independent work, right? Again, to remind you, you need 7.6 points per week, technically. So that means you should have like 15.2 by the end of Sunday. Good time to remind you about labs, speaking of Sunday. Your lab for lab 2, the pre-lab, is due on Sunday. Make sure you start now. Even if you don't intend on doing it now, I would start now. Because you've had access to it, that's why there's no late work allowed, because you've had access to these things for a while. So if you miss the deadline and you say, well, my computer didn't work on Sunday, so well, you should have been working on it before that, or my internet was down, whatever the case may be. Also, or more importantly, if you look at it, like the first time you look at it Sunday evening, you're like, oh, this makes no sense to me. then it's probably too late to get my help. So at least look at it early, and then make sure you think you understand it. That way, if you do need my help, you can get it when there's time. Any questions about that? Yes.
So is that pre-lab for next week's lab?
Yes, the chemistry lab 2. And if you look on Google Classroom, it'll say the due date. Like if you go to the stream at the top left, there's 2 things that are due, and it says what they are and when they're due. So the first thing that's due is last week's lab that is due today at midnight, right before midnight. And then the pre-lab from next week's lab, which is lab 2, is due Sunday by midnight. Okay, go ahead. That make sense? All right. What else? Red Fridays, yeah, so we've already done this on one other person. I was gonna say, you get extra credit for wearing red on Fridays. Office hours, so next week I intend for Friday to only be online office hours. Just giving you a heads up. If you feel like you physically wanna come talk to me next week, make sure it's on a Monday or Wednesday. Or if you really, really need to talk to me in person on a Friday, let me know before then, because right now I intend to do office hours from home online. Good? All right, any other questions? I think we're pretty clear now. Make sure you email me, let me know you came in late, otherwise I will forget.
I have breakfast.
Okay, and then for, speaking of the Red Friday thing, it's only the 2 of us, but of course, whoever can take our picture for us would also get a little bit of extra credit too, because I need somebody to take our picture, if we have time for it, and she's up for it. Anyway, any questions? Okay, today we're gonna finish up chapter 2, and then I'm gonna stop recording, and then I'm gonna re-record, start recording again, and we'll start chapter 3. We're a little bit ahead of schedule, and that's good. So at this rate, that means probably not next week, but the week after that, we'll have our first exam. So heads up. So go ahead and start thinking about which day you would want, Monday, Wednesday, or Friday, works best for you. Usually I leave it up to you guys to an extent. Anyway, getting back into chemistry, obviously we already finished the main bullet point, which was some basic chemistry. We're now working on the second main bullet point, which is water. And if you haven't watched those videos I posted, those 2 videos, these 2 chemistry videos, they're short. What are they, like 6 minutes, 12 minutes long, something really short. And they really are informative. Basically, they say everything I'm saying, but in a more entertaining way. So watch those if you get a chance. Anyway, we talked about the cohesion of water, we talked about how water molecules sticking together. Without that, we wouldn't have life, right? Or at least we wouldn't have life as we know it. Couldn't have big tall trees, for example. And then we talked about how water moderates temperature. So without all the water we have on Earth, it would be, parts of Earth would be too hot to inhabit, other parts would be too cold. Again, probably couldn't have life on Earth without that. And now we're going to talk about the biological significance of ice floating. Now, before we do that, we're going to talk about how ice floats. Speaking of which, the first word for attendance is going to be ice. Ice is the first word for attendance if you're online. Anyway, what happens usually when you heat something up? Forget about the fact that we're about to talk about water. But like if I were to heat up a piece of metal, what usually happens to it? Does it stay about the same size? Does it get larger? Does it get smaller? What usually happens when you heat something up?
Smaller.
It's a good guess, right? It's probably intuitively, people know what happens. Yes. So, sorry, maybe I shouldn't have said it that way. I'll put it a different way. What happens when you cool something down? How about that? So if you were to have a piece of metal and you were to cool it down, technically what should happen to it? No guesses? You don't need to know it. Would it water? Well, not water, because we're about to get to that. But it would yeah, you could argue that. But when things get colder, they get smaller, right? Because think about it. Like I said yesterday or Wednesday, when things heat up, what that really means on a molecular level is the molecules are moving faster. Therefore, things expand, right? And when they cool down, they're not moving as fast, so they compress, especially if we're talking about a gas. Water is different, though. Water is interesting because at least once it hits freezing point, once it gets low enough to freezing point, it gets larger. And we're going to talk about that. As the water molecules once they get cold enough, they actually move apart. And that's a very unique thing. But you do need to know that. Know that once they get cold enough, they move apart. And because the frozen form of water is larger, so to speak, or less dense is a better word in this context, because it's less dense than liquid, it floats. And you need to know that. That's why ice floats. Because the frozen water, the ice, is It's less dense than liquid. Make sense so far? The next slide I'm going to show you shows you why it's less dense than water. Why the ice is less dense than the liquid water. All right, moving forward. This is why. So this is kind of a picture. It would be better if it was animated. Here's a picture of liquid water. Well, what should happen, you can kind of see it. So see how those water molecules look blurry? It's not because of the screen or the projector. It's because the person who made this picture tried to make it look like those things are moving. And they are. They're vibrating, they're spinning, they're moving around. But what happens is once it gets cold enough, right, it takes away that energy. So they stop moving around. And eventually they get so slow and the hydrogen bonds are so strong, or at least strong enough at that point, that they just stop moving, right? And they just sit there and they get this crystallized pattern. And because of that, they are actually larger. Again, because of that, they are less dense than the liquid, and therefore, as you can see right here, ice floats. Obviously, I think the easy thing for you to remember is that ice floats, right? Everybody has had a glass of water or anything where the ice is in there and it's floating up top, right? So again, the reason, or what you need to remember is why. It's because it's less dense. And to help you remember that, now that I'm going to test you on that, is what you have on the slide right here. Why is it less dense? Well, it's because as things lose temperature, the molecules move around less. And in the case of water, once it hits freezing point, they just, now that they're not moving, kind of crystallize. And again, notice these water molecules look nice and clear, right? Unlike these, because again, the person who made those pictures trying to indicate those things are moving around, those things are not. So why would that matter? Any guesses why ice floating would matter for life on Earth? Because that's really what we're talking about, is the importance of the biological importance of ice floating. No guesses? That's okay. Well, let me ask you this. What happens, you guys have probably seen it, this isn't the book example, but this is something you may have seen. What happens when it gets really cold, cold enough, and there's ice on a lake? Where does that ice start? Does it start at the bottom? Does it start at the top? Does the whole thing just freeze at once? What happens? I think so. You just start up top? Yeah, right? You guys have seen it, right? And hopefully around here you've heard like, hey, don't go on that ice because you don't know how thick it is. The point is there's ice and that's where it starts, right? It starts up top. Same thing with the ocean. As a body of water cools, the ice layer forms on the top. But that thing acts as an insulating blanket. So even though it is ice, right, it's solid water, it's still water. Meaning all those things I told you when I first started talking about water are still true, which is that it takes a lot to make the temperature change. So we don't think of ice as a blanket because it's cold to us, but it is relatively warm, right? So let's say that the layer of ice, obviously when it first freezes, is 32 degrees Fahrenheit, 0 degrees Celsius, depending on some things. We'll just say that and keep it simple. That's how cold, let's just say it's 0 degrees Celsius. That's how cold the ice is. But the air on top, as it gets colder and colder, it could be, I don't know, negative 10 degrees Celsius, right? Really cold outside. But the water is insulated from that because it has that negative or that 0 degrees Celsius blanket of ice. Does that make sense? So even though we think of ice as cold, because it is, it's all relative. So it protects the water under that from the relatively colder air. Why does that matter? Well, that keeps things from freezing over, right? Otherwise, we would have frozen, like, the ice, or excuse me, the oceans could just freeze up. Everything under it would just freeze up. All the lakes and rivers would just freeze up. So yeah, that's why it's important. So the fact that it floats helps protect things. I remember when I was, I won't say a kid. Yeah, I guess I was a kid. Anyway, I was living in Florida and it had a big freeze, which is not very normal. And I remember what they did to protect the orange groves was spraying down with water. I thought that was weird. And they're basically just trying to ice them up. Because again, it'll freeze. So in that case, it won't run off. Like, usually when you spray a plant with water, the water runs off. But if you spray it when it's frozen, it freezes. And it acts like a blanket. Because again, the ice is relatively warmer than the air around. Any questions? All right. Next thing we're going to talk about is the water is the solvent of life. Man, I wish I would have brought a have like these kids' Legos. Should have brought them, I usually use them. So imagine, you guys know what Legos look like, right? Imagine if I had like a big old block of Legos, and they were all two colors, red and green. And I gave it to her, and I said, here, can you please make me a red box? We'll just stick with a box. I already have a box, but I want you to make me a red box. What's the first thing you would need to do if I gave you a big box? When I say box, I mean they've been put together. Not like a box of them. A cube. Give me a cube of red and green Legos. And I said, I want you to make me a cube, a blue one, excuse me, a red one. What would be the first thing you would do?
Break it apart.
Break it apart. Perfect. Good. So keep that in the back of your mind with what we're about to talk about. Before we do that, I need to give you some vocabulary words. The first word is solution. You need to know what a solution is. One, because I might test you on it, probably will test you on it. Two, because we're going to use this word quite a bit. A solution is a liquid or the homogeneous mixture of two or more substances. Really, the way you need to think of it is it's a liquid that has something mixed into it. That's even like common. You just know it as with the common words. It's a liquid that has something mixed in it. So tea, that's a liquid, right? Because it has tea infused into it. Coffee is a solution. Or to make a margarita from scratch and boil some water and put some sugar in it to make simple syrup. That would be a solution. That water with the simple solution. Or, excuse me, the simple syrup would be a solution. So if a solution is basically just liquid with stuff mixed into it, then let's talk about how you make it. Well, the liquid you use to do the dissolving is the solvent, and the stuff that you dissolve is the solute. So you might get a question like that on the exam. So for example, I might say, again, I made some simple sugar for my margarita. What is the solvent? What is the solute? What is the solution? In that case, the solvent would be the water, the solute would be the sugar, the solution would be the simple syrup. And obviously, it's not important that you understand how to make a margarita, but you need to understand what the solvent, solute, and solution are and how they're related to each other. It just so happens, so far these things I've been talking about, I keep talking about the stuff that's dissolved in water, and that has a name too. When it's dissolved in water, it's called an aqueous solution. So if I were to dissolve something in rubbing alcohol, that would not be an aqueous solution, right? Because that would be rubbing alcohol, not water. All right. Any questions about this slide? All right. This nomenclature, these vocabulary words, is going to be important in maybe the next chapter. If not, no, not the next chapter, but the chapter after this. So this will come back. It's important. Anyway, what's this have to do with water? Water can dissolve a variety of solutes, and it provides a medium for chemical reactions. So basically, I'm not even going to read all this. Basically, what all this says is water is really good at dissolving stuff. Why? Because as you know, water is a polar molecule, right? We talked a lot about that. Those electrons love hanging out with the oxygen, so that's a partially negative. Hydrogens are partially positive because of that, right? So it's charged. Remember what else is charged, for example? Salt, right? Salt, sodium chloride. We said sodium gave up an electron, so it's positive. The chloride, oops, it's about to draw an acid. I don't need to do that. The chloride is negatively charged because it took the electron, and that's the example we have here. So because of that, you can see here this chloride has been ripped apart by all these positively charged hydrogens are surrounding it because it's negative. Meanwhile, the sodium has been ripped away because it is surrounded by those negative oxygens. So this goes back to what I was asking her about the Legos. I needed her to make a red cube of Legos, but I didn't give her a bunch of red Legos. I gave her a bunch of red and green Legos put together. So just like your body needs sodium, just because you eat salt doesn't mean you've given it sodium, right? It's not sodium. It's sodium chloride. So to get the sodium, you need water. You need something to take it apart. So it's not trivial. And again, water is just really good at doing this with a lot of things. So that's why it's so important. It's almost a universal solvent, almost. Anyway, any questions about this? This would be a decent independent work topic if you're interested in it. Like, what are the other things commonly dissolved in your body by water? Just a question you could look up and answer. It'd probably take you 5 minutes and you get some independent work. So no questions about this. All right, the next one we're gonna talk about is really important for next week's lab. Let's talk about acids, bases, and pH. You're probably already familiar with the term acid and base and pH. No judgment on you guys, but I would assume you're probably not very, very familiar with it. You've heard the terms, probably know a little bit about it, but most people don't really truly understand it. Which if you've had chemistry, you probably do. But let's move forward. First of all, what is an acid? You need to know this. There's a lot of different ways to define acids, but the way we're going to define them is something that releases hydrogen ions. And in the books you read, and the conversations we have, and the labs you do, and the study guides you take, and the exams you take, you might see it like this, where it says hydrogen ions spelled out, or you might see this symbol, H+. Either way, that's what an acid is. An acid is something that gives off hydrogen ions. So if you were to take water and dissolve something into that water, that's what it's putting off, is an acid. Another topic for independent work. If you feel confident in this, you could look this up. What are the other definitions for acids? Only if you feel confident, because if you don't feel really confident in this, it's just going to confuse you. So think about that. So any guesses to what a base might be? Or let's see if we can get you to it at least a little bit. We know that an acid releases something positive, right? Yes, technically it's called a hydrogen ion, H+, but right now let's just focus on the fact that an acid is something that releases something positive. So that being said, what do you think a base might release? Something negative, right? Because we know they're opposites. Even if you aren't really good with chemistry, you probably know that bases are opposites of acids. So yeah, there's two different ways of looking at this. Either way, it's the same thing, just a different way of saying it. A base is something that accepts those hydrogen ions that an acid puts out. Why? Because it's putting out basically the opposite. It's putting out something negative, hydroxide ions. And again, we talk about this. When you see it in lab, when you see it in the textbook, when you see it on study guide, when you see it on the exam, it might say hydroxide ion or it might have the OH minus. So know them both, know the whole thing. I will also tell you this, I'm not going to try to trick you. So if I have a question about acid, I'm like, which one of these is an acid? Or an acid puts off what? I'm not going to give you a bunch of things with a plus behind it. There's only going to be one thing with a plus, because it's multiple choice. So anything with a plus on it, that's the answer for acid. Same thing with the base. Anything with a minus on it, that is the acid, base. So if I ask you the definition of an acid or a base, and you're looking at the multiple choices, it has a plus on it for acid, that is the correct answer. If it has a minus, that is a base. Yes?
Wait, so does it release hydroxide ions and then replace them with hydrogen ions?
Yeah, basically it's like, all right, so there's these H pluses in the solution, and this thing is putting out the OH minuses, and they come together because it's actually H2O, right? One oxygen, two hydrogens. It's just the opposite. And I don't like, this is the way your book explains it, but it almost sounds the way your book is explaining it, sounds like that base wouldn't exist without acids, but that's not necessarily true. So another way you could look at this, if you want, if it makes it easier, just forget this first part. Yeah, it accepts the hydrogen ion, but if it makes it easier for you, just think of it like this. Bases put out hydroxide ions. Because again, this comes directly from your book. I could rewrite this correctly to say, if I told you what a base was first, and didn't tell you anything about accepting anything, right, because it's the first thing I told you, then I could say an acid is something that accepts the OH, the hydroxide ions, right? They all accept each other. It's not like one, this is accepting that. Technically, they're accepting each other. But that's the words, it's the verbiage from your book. Just know that they come together to neutralize each other. Or more importantly, what you really need to know is acids put out hydrogen ions, and base put out hydroxide ions. That's the most important thing. This will make a lot more sense when I explain the pH scale. Then you really know how you need to think of bases and hydroxide ions. Bases and acids. There's still more to this slide. As I was saying about the pH scale, it describes the acidity, which is the measure of concentrations of H plus in a solution. So you know what a concentration is, right? So how many of you have had like really, really sweet tea? And how many of you have really, really weak sweet tea? So maybe some of you haven't. I don't know. I thought a lot of people would be used to that. But anyway, or a really, really strong mixed drink, because you guys, I don't know, some of you too young for that. Really, really strong coffee versus really, really weak coffee. If it's really concentrated, right? Again, using sweet tea as an example, you would say it has a lot of sugar in the solution. If it's really weak, you would say it does not have a lot of sugar in the solution. pH is the same. So we're not looking at sugar or alcohol or coffee or tea, whatever. For this, we are measuring the amount of H plus, the amount of hydrogen ions. Here's really what you need to know. This is really important. We'll be tested on this. You'll have questions on this. 0, if we're looking at the pH scale, is most acidic, and 14 is most basic. You need to know that. I might give you 2 random solutions and give you their pH and say which one's more acidic.
So which one were you? Or all two?
Yeah, you need to know all of it. I'm just saying this is probably as far as the hardest, the relatively hardest stuff, and the stuff that's also going to be on the exam. You need to know that 0 is most acidic and 14 is most basic. So again, if I gave you 2 solutions and said, this one has a pH of 10, this one has a pH of 11, which one is most acidic? You'd say the one with pH of 10, right? Because it's closer to 0 than the one of 11. Or did I say basic or acidic? Okay, good. So that's how the questions are going to go. I'm going to write it down to make sure I'm not messing up. I'll give you a liquid, and I'll tell you what it is, and I'll tell you the pH. And maybe I'll say it's a pH of 7. Liquid A is the pH of 7. Liquid B is a pH of, 4. And there's so many different ways I could ask this question, and I'll get your question here in a second. I might say, which of these is more acidic? And that would be the answer. Or I might say, which is more basic? And that would be the answer. Or I might say, which one has the higher concentration of hydroxide ions, right? The OH minus. That would be the answer. Or I might say, which one has the higher concentration of hydrogen ions, the H plus? And that would be the answer. See all the different ways I can ask the same question. All I'm doing is asking which one's more acidic or basic. There's all these different ways I can ask them. So when you're studying this, just think of it that way. And what was your question?
So like past 7, it's obviously more basic, or towards 14, isn't like an alkaline.
Yes, and we'll talk about that here in a second. Yeah, she was asking about, basically she's giving it more nomenclature. So the term alkaline is usually used when we're talking about something more basic. But for this purposes of this course, you don't even need to know that. But definitely know, again, 0 is most acidic, 14 is most basic. Here's the thing that really trips people up. And I'm going to talk about it when I actually show it to you on the screen, but each step in the pH is a multiple of 10. That's also going to be important because, just to make this a little bit harder, when you see this question on the exam, instead of just saying which one's more basic, I'm going to say how much more basic is it. So you can say, okay, this one's more basic. So 4, 5, 6, 7. So that's 3, and each one's a times 10. So 10, 100, 1,000. So the answer is A is 1,000 times more basic than B. Or A has 1,000 times more hydroxide ions than B. Or B has 1,000 times more hydrogen ions than 7. Or B is 1,000 times more acidic than A. So I know that sounds like a lot, but again, if you start with 0 to 14 and work your way forward as you're studying, then you're okay. Anyway, let's move forward. We're not done talking about this, but we'll move forward. Here's a kind of a decent picture coming up. It's a little bit hard to see. So we have a basic solution on one side, acidic solution on the other, and a neutral solution. So if you were to count them, you can see the basic solution has a lot more hydroxide ions, right? It has more of those negatives than the pluses. That makes it basic. Notice there are some pluses, because sometimes there are. Notice the acidic solution. It just has more of the pluses than the minuses. There's still some minuses, but it's mostly the pluses. And of course, the neutral, if you were to count them up, has the same, right? Same number of pluses as minuses. Any questions about that? That's just a visualization. I don't think you'll get that on the exam. Either way, if you do, it's the one. If it has more minuses, basic. More pluses, it's acidic. If it's equal, it's neutral. So here we go. Here's the next thing. You do not need to memorize all these examples. For sure, I'm not going to test you and say, what's the pH of household ammonia? Actually, that's not true. I might test you and ask you that, but if I do, I'm going to give you this exact picture. Right? So you don't need to memorize all these different pHs. But if I give you this and say, what's the, again, pH of household ammonia? It is multiple choice, right? So if it's 12 or 11, you would know that's the correct answer. So the choices would probably say something like 11.5 or 9 or 6.4 or 3.2, whatever. But you could decipher that, right? If I gave this to you on an exam, pretty simple. All right. Another thing to know about this is what I was showing you earlier. You will get a question like this, and you will get a pH scale. Not that it helps that much, but I will ask you, what's more basic? Pure water, which is 7, or, and I said 4 here. There's nothing directly at 4, but let's say tomato juice. Let's assume tomato juice was. And then that's how the question would go, right? How much more basic is water than tomato juice? And again, you would say, okay, from 4 to 7, so 1, 2, 3, and a multiple of 10, so 10, 100, 1,000. So I know I always recommend doing study guides, but I really recommend doing the chapter 2 study guides, because this is one of those things where even if you haven't memorized, it helps to have some practice working those problems. If I get a chance, maybe I'll make a little quiz where it's nothing but these kind of problems, and I'll put it out there for independent. If you want to do it and get some points, you can, and if you don't want to, that's on you. But yeah, I might do that if I get the time. Just so you can have some practice. Anyway, any questions about this? All right, this is just a meeting. Yes.
So, what would be considered neutral? Like, is it from acidic, is it 0 to 6.9 or?
Good. Technically, it's 7. Exactly at 7 is technically neutral. 6.9 is so slightly acidic. Another thing to consider, now that you've asked that, in this next meme I'm going to show you kind of talks about this, but we'll talk about it while it's up here since you've asked. A lot of times this conversation is, when we talk about these things, a lot of times it is relative. So I would say seawater compared to milk magnesia, seawater is a lot more acidic than milk of magnesia. Technically, it's above 7, right? So technically they're both basic, and it's all relative, right? So this thing has more H+ ions than this thing, so it is more acidic. Not that you need to know that for the exam. I'm not going to get that tricky on the exam. But just for your own knowledge, when you hear somebody say something like that, like seawater is a lot more acidic than bleach. And I don't want you to be like, I remember from seeing it on the pH scale, seawater is basic. And it is basic, but not as basic as bleach. Do you have another question?
Yeah, so whenever I'm writing the range for acidic, do I write like 0 to 7 or 0 to 6, 9?
Good question. And you know what? I guess I wouldn't worry about that. Because I won't ask you that. At no point will I say, just give you one thing and say, is it basic or is it acidic? But you know what? I'll go ahead and tell you anyway, because yes, technically, if you want to look at it that way, anything from 0 to 7 would be considered acidic. 0 to 6.99999 infinity, right? And anything from 7.0000001, infinity up. So this is all acidic, or basic. This is all, well, that should be up there. This is all acidic. Anything above 7 is basic, anything below it is acidic.
Are you going to ask if the solution is neutral?
No, probably not. Or I might say, what is neutral? And you just, yeah, that's a good number to know. Know that 7 is neutral. But again, I don't know if I'm gonna ask you if something's, I don't think I'll just give you one thing and say, is it acidic or basic? Because to me, it's all better to think of it relatively. Like relatively, black coffee is more basic than grapefruit juice, right? Because you can see, because it's higher on the scale. Even though they're both technically acids, that one's more basic. And I prefer you to think of it that way. Another thing to say, since we're talking about this anyway, again, these are multiple choice exams. There's about 50 questions. So if you're doing this, and you can't seem to grasp it, and this is so overwhelming you, just remember, there might be like 1 or 2 questions about it, right? So if you get everything else and this is the one thing tripping you up, then be like, whatever. I mean, try to get it. I mean, come to me for help, but I wouldn't.
How much time do we got to finish the exam?
50 questions, 50 minutes. Because they're online, it's a good time to remind everybody what we talked about on the first day of class when we talked about syllabus. The exam will be about 50 questions, give or take. You'll have 50 minutes to do it. Because you'll be doing it online and it's supposed to be closed book. You're not supposed to use the book, you're not supposed to use your notes, you're not supposed to watch the video, you're not supposed to have help. And you can't really look up 50 questions in 50 minutes. That's why I do that. So if anybody wants more than 50 questions or more than 50 minutes, all they have to do is contact me and we'll find a different time for you to do the exam where we can do it together. And then I don't care if it takes you 5 hours, as long as I know you're not using any outside help. I don't care how long it takes you. I'm glad you asked. Any other questions? That's a good question. Good reminder. Because I gave you a lot of information on Monday, and that first Monday. And I know I said that, but I gave you guys a lot of information. Yes?
So we're just gonna take the test at home.
Yeah, test will be at home wherever you have a computer. And of course, some people don't like doing that. If you want to come in and you want to take a paper test, let me know beforehand. I'll print one out for you and do that. Or again, if you want to take a paper test and come meet me in office hours so you can do it in longer than 50 minutes, I'll do that too. Good questions. Any other ones? Okay, so anyway, going back to this idea that things are relatively acidic and relatively basic, right? I found this pH. Who here knows what dihydrogen monoxide is? See, most people don't. That's okay. It sounds scary, but dihydrogen monoxide is another word for water. So this is a great meme from some fake Facebook account called Dihydrogen Monoxide Awareness. Because a lot of times, people who have try to scare you about things like GMOs or chemicals, they use big words, things that, because the big words sound scarier. And they'll say things that are true but sound scary. So let's break this down. Dihydrogen monoxide is an acid with a pH level of 7. Now, technically, again, I'll get you in a second. Technically, it's all relative, right? So technically, a pH of 7 would be more acidic than bleach, for example, right? So that's not a lie. And then it says that's the highest, or that's a higher pH level than any other acid. And you could look at it that way, right? Because anything higher than that would be basic. So all these things are true and not scary, but it's presented in a scary way. Of course, it's a joke, but you could, somebody out there seeing this and like, oh my God, they're putting dihydrogen monoxide on my kids' drinks? What? I'm calling the school board. It's ridiculous. Anyway, question?
Isn't hydrogen monoxide actually like hydrogen monoxide?
Hydrogen monoxide is just a chemical word for water. Or excuse me, dihydrogen monoxide. So
So
two hydrogens, one oxygen.
What's the like the gas that's
Carbon monoxide?
yeah?
Carbon monoxide is a deadly gas. We might talk about that later. Good question. But anyway, yeah, you don't also, and I'm glad you asked that because you don't need to know this. That's not going to be on the exam. Speaking of which, the second word, I've been off my game for this. The second word for attendance is going to be acid. Why not? But anyway, yeah, I'm not going to ask you anything about this. My point is, as a critically thinking, college-educated citizen, you should see stuff like this and think about it. That might be something else. That's a good independent work topic too. Go look up the chemical name of some really common ingredients, like starch, sugar, whatever it is that is not really scary. Look up the chemical name, and you could really scare somebody. They're putting this in your kid's cereal. They're giving it to them at school for free lunch. Yes.
You want us to know though that water is hydrogen monoxide?
Good question. You don't need to know that. Anyway, let's move forward. another term you need to know is buffers. You need to know what a buffer is. Basically, it's something that makes it hard to change the pH. So if you dump a bunch of acid into a liquid that has no buffer, it's going to get really acidic really quick. If you dump a bunch of the same amount of acid into a liquid that has a buffer, it's not going to get as acidic. If you dump a bunch of base into a liquid that has no buffer, it's going to get very basic. If you dump a bunch of buffer into a liquid that has a buffer, if you dump a bunch of base into a liquid that has a buffer, it's not going to become as basic. So that's the most important thing you need to know. Buffers resist change in pH. After you've mastered that thought, then you go on to understand how that works, and it's basically this. It basically just does the opposite. So when there's a lot of H+ ions, it just kind of absorbs them up. When there's not enough, or in other words, when there's a lot of OH- ions, it puts out the opposite. It neutralizes stuff. How many of you have ever had coffee? Well, hold on, first let me say this. I'm not going to go to the last slide, I'll just remind you. As it showed on that pH scale, for your blood is a pH of 7.4. If it goes too far above or below that, you will die. Good independent work topic too. First of all, there's a name for when it goes too high or too low. You look that up. And also, what's the number? You'd be surprised at how low it is. It's a very low range. If it gets too high or too low, you die. Actually, I will back this up. Let's talk about buffers. But let's look at this. There's your human blood, right? 7.4. How many of you have ever had black coffee? Coffee in you, okay? They have. I'm drinking it right now. How many of you ever had anything with tomato juice in it? Like a V8 or pasta sauce, right? You guys, or pizza sauce, right? So that's pretty acidic. How many of you ever had a soft drink, right? Or grapefruit juice? Or maybe put some lemon in your water, right? How many of you chug bad acid? No, I'm just kidding. But anyway, for all of you who have had these things or have, did you die? Are you still alive? Are you still alive, right? The reason is because you have buffers in your system. You drank some really acidic stuff, but you have a buffer in your system. So you didn't die. So again, if you fluctuate too much from 7.4, you will die. But that kept it from happening. Same thing here. Well, actually, it's not on here, is it? Milk isn't on here. Milk and magnesia is, but
Wait, what is milk and magnesia?
milk is actually a little bit, I think it's around here. Milk is actually a little bit acidic, believe it or not.
What's milk and magnesia?
Oh, I know it's some sort of like over-the-counter medicine. I think it's used for heartburn, maybe.
Yeah.
You can look it up if you want, because I don't remember. I used to be a pharmacy tech, but then again, it was over-the-counter, so in my defense, I never had to work on it. But anyway, so yeah, that's the point, right? Buffers keep you from dying. Also, when people tell you things like, oh, the water's alkalized, it's good for you. That's a bunch of BS. So what's going to happen immediately is it's just going to get neutralized. And there's another meme out there I need to find where Gwyneth Paltrow says something like, she starts her day with an alkalized water with lemon juice in it, like that she puts lemon juice in it. It's like, well, you just neutralized it. Yeah.
So what happens to your body when you're in an alkaline diet?
Alkaline diet, nothing. Those are all basically useless. Unless it's doctor ordered, and I don't think, like it maybe really has some sort of issue where like you're producing too much acid maybe. And I'm saying maybe, I don't even know that. But generally speaking, when people give you those things, like, oh, you should eat more alkaline food or drink more alkaline water, it's generally a bunch of woo. Usually it's generally pseudoscience because it all equals out. Think about it. Like, again, if you can drink lemon juice, like I've seen my kids eat lemons, it doesn't do anything bad to them.
So is there any health benefits of doing an alkaline diet?
Not that I'm aware of. I really do think it's pseudoscience. But the key word there is think. I'm not an expert in that. You should look it up if you want. But make sure when you look it up, you pay close attention to the source. See if you can find any peer-reviewed articles that say that it's actually healthy or not. I don't even know what's in it. It's probably a bunch of greens, right? In that case, it is healthy. Not because it's alkaline, but because greens are really good for you. You get a lot of vitamins, nutrients, fiber, you know that. So the next word for Attendance will be Gwyneth Paltrow, since we just talked about her crazy. I like her as an actress, but she's got some crazy science views. Anyway, moving forward, again, you know what a buffer is now. You also now know why it's so important. We'd be dead without it. Your book also points this out. I'm not going to ask you about it on the exam. This will come back to you if you take the 108, or if you already have 108, I 108. But there's also buffers in the ocean, right, to prevent the same thing, but it's not foolproof. So there's so much carbon dioxide being dissolved in the oceans right now that even the buffers can't keep up with it. So what's happening is it forms an acid, right? Carbonic acid is what it's called. So that lowers the pH in the ocean, and that actually really is bad for it. Here's a visualization of what we're talking about. You mix the carbon dioxide with the water, you get something called carbonic acid, and it's killing things. And it looks like this. And that's the picture we started the chapter with, if you remember. Bleached coral, right? Because it's getting too acidic. Anyway, every chapter we do has this evolutionary connection, and I'm always going to skip it. I'm never going to test you on it. But read it if you want. Ask me questions about it if you want. These questions will be on the study guide, because it's no harm. You know, it doesn't matter if you barely pass the study guide. It doesn't matter. It's independent work points, right? So it doesn't matter. Anyway, so that's where we will end chapter 2. I said we were going to jump into chapter 3, but we only have less than 6 minutes, so we won't do that. We are done for the day. If you came in late, make sure to email me. Do you want to do the picture?
Sure, why not?
All right, so I need you to volunteer to take a picture. All right, so when you email me, tell me you were late, make sure you also remind me to do the picture. And for those of you online, make sure you send me the email with those keywords before my name.